Hello, my name is Ardi and we are going to solve problem 4.11 from Nilsson and Riedel book. So the question is, use the node voltage method to find the branch currents IA through IF in the circuit shown in figure P4.11 and then find the total power developed in the circuit. Okay, maybe we need to name all the nodes. Okay. I think this node here will be our node V1. Okay. And this node here is our node V2. Good. And now this one will be node V3. And I want to set this bottommost node here as our ground so that the voltage there is 0. Okay. And we already given the direction of the current by the problem, so we can just use that. And this node here is 80 volt from the ground, so that will be 80. Okay. Now we can do KCL at V1, V2, and V3. Okay, let's do exactly that for question A. Okay, let's do KCL at node A. Okay, not VA, V1, I mean. And KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay. Here, the only current that goes in is IB here, but then IB is 80 minus V1 divided by the resistance between them, that will be 800. Okay. And then what else? IC is going out, so we will have that will equal to V1 minus V2 divided by 500. Okay, divided by 500. And then what else? We will have this IA here is also going out from V1. And that will be V1 minus V3 divided by 1 kilo ohm. That will be 1000. Okay, what can we do from here? I think we can multiply both sides by 4000, right? We'll have multiply this by 4000, so we can get rid all of the denominator here. 800 and 4000 will cancel into 5. Yeah, 5, right? Okay, so we will have 5 multiplied by 80 is just 400. So we'll have 400 minus 4000 V1. 4000 V1. No, not 4000 V1. Are you stupid or what? That will cancel into 5, right? So we'll have 5 V1. Okay, and 500 and 4000 will cancel into 8. So we will have 8 V1 minus 8 V2. And then 1000 and 4000 will cancel into 4. So we'll have 4 V1 minus 4 V3. Okay. So we will have 8 plus 4, that will be 12. And 12 plus 5, that will be 17, right? 17 V1. 17 V1. And then what else? I think we only have V2 here, so we'll have minus 8 V2. And then minus 4 V3. Okay, all of that will equal to 400. Okay, nothing that we can do. Maybe let's save this as equation number 1. Okay, now let's do another KCL, but this time at node V2. KCL at node V2. Again, the sum of the current that goes in will equal to the sum of the current that goes out. Okay, what can we do from here? We will have V1 minus V2 divided by 500. Okay, V1 minus V2 divided by 500. And that will equal to, I think, V2 minus 0 divided by 3000. V2 divided by 3000. And then this one there. So we will have V2 minus V3 divided by 2 kilo ohm. That will be 2000. 2000. And we can multiply both sides here by, I think 6000 is good, right? 6000. Because we can cancel out all the denominator. So for this one, I will have 12V1 minus 12V2. 12V1 minus 12V2. And then this one will be 2V2. And then this one will be 3V2 minus 3V3. Okay, and we can just move all of them to the left hand side. So I'll have 12V1 minus 12 minus 2 will be minus 14, and then minus 3, that will be minus 17. Minus 17 V2, and then plus 3V3. Plus 3V3, and all of that will equal to 0. Okay, let's have this as equation number 2. Okay, now let's do one other KCL, but I think the board is full. Let's clean up the board first. Okay, so far we got two equations from KCL at node V1 and KCL at node V2. This is the two equation. And now let's do the last KCL. We need to do KCL at V3, right? KCL at V3. Okay, let's state the KCL. The sum of the current that goes in will equal to the sum of the current that goes out. And there are two currents that goes in, right? IA and ID. Okay, so we will have, for IA, we will have V1 minus V3 divided by 1000. Okay, and then this one here plus we will have V2 minus V3 divided by 2 kilo ohm, so we'll have 2000, and then that will equal to V3 divided by 250. V3 divided by 250. Okay, I think for this one I can multiply both sides by 2000, right? And we will have this one here. We will have 2V1 minus 2V3. 1000 and 2000 will cancel into 2. And for this one, 2000 will cancel each other. So we will have V2 minus V3. And 250 and 2000 will cancel into 8, right? So we will have 8V3 here. Okay, now let's do some simple algebra. 2V1 plus V2. Then minus 2 minus 1 will be minus 3. Minus 3 minus 8, that will be minus 11V3. And that will equal to 0. And this is equation number 3. Okay, maybe let's copy that there. And I think I will use calculator for solving them. Okay, let's clean up the board first. Okay, we have 3 equations and 3 variables. Let's set up our calculator. Set up equation solver is number 5. 3 variables is number 2. And we can just plug the coefficients and results. So we'll have 17 minus 8 minus 4. And then 400. 100. Okay, and then we will have 12, and then minus 17, and then 3, and then 0, and then we will have 2, 1, minus 11, and then 0. Okay, we will have that V1 is 40 volt. Okay, oh, nice number. V1 is 40 volt. And then what else? We have V2. V2 is 30 volt, which is also a nice number. Okay, and what else? V3. V3 is 10 volt. Okay, V3 is 10 volt. And I think we are set for finding out IA, IB, IC, and until IF, right? Okay, now let's do one by one. IA. IA is 80 minus V1 divided by 800. So we will have 80 minus 40 divided by 800. So we'll have 40 divided by 800, and that will be 0.05, right? Ampere, or we can convert this into milliampere, which is 50 milliampere. That is IA. And then what is IB? IB is V1 minus V3 divided by 1 kilo ohm. Okay, and then what is V1 and V3? 40 and 10. So I will have 40 minus 10 divided by 1K. And that will be 30 milliampere, right? 30 milliampere. Okay, and for IC, okay, I think we can get IC here, which is V1 divided by V2. V1 minus V2 divided by 500 ohm, or 0.5K. Okay, V1 minus V2, that will be 40 minus 30 divided by 0.5K. 10 divided by 0.5, that will be 20, right? So we have 20 milliampere. That is IC, and we can calculate ID. ID. Okay, what is ID? V2 minus V3 divided by 2K. V2 is 30. V3 is 10. So we will have that divided by 2K. 20 divided by 2 is just 10. So we have 10 milliampere. Okay, that is for ID. And let's find out IE. IE is just V2 divided by 3. V2 divided by 3. What is V2? V2 is 34. Remember, 3 is 3 kilo ohm. So I have 3 kilo ohm. And so we will have also 10 milliampere. And lastly, we will have IF. IF is just V3 divided by 250 ohm, or 0.25K. And V3 is just 10. And divided by 0.25K, that will be 40 milliampere. And that is all the current IA through IF. And this is the answer for question A. Okay, now let's do the last question. Find the total power developed in the circuit. And I think we can just use this voltage source, because that is the only source that can give power to the circuit. So we will have P is equal to 80 multiplied by IB, right? Because all the current will be equal to this one here. So we need to multiply this by IB, which is 30 milliampere. So we will have 2400, and the unit here is milliwatt, or 2.4. And this is the answer for question B. And that is all for problem 4.11. See you in the next video. Bye bye.